Hello, and welcome to this lesson on comparing functions. So in this lesson, we're going to be looking at functions in different forms. So some as tables, some as graphs, some as equations, and then we're going to be comparing them and some of their different features. Okay, so the essential question says, how do I compare functions? Did you know that oftentimes you can use features of functions, like the initial value and the rate of change, we looked at those in the previous lesson, to compare two functions, like who starts with more money, who makes more money per hour, who would have more money in 8 hours. These are all different things you can do once you have the functions. And that's really, what this whole lesson's all about. That's what the kind of questions we're going to be answering a lot of. There is no new vocabulary, which is awesome, so let's get to it. So here, both relations represent linear functions. In fact, every single function we're going to see here today is a linear function. Which function would be steeper or more vertical if you were to graph it? Okay, so we're looking at this. We have a couple of different ways we could do this. We could graph them right now. I could take out a piece of graph paper and I could graph this equation. I could graph these points and draw a line through them and see which line is steeper. That seems like a lot of work. I could try to take out my graphing calculator and I could graph this equation. I don't even think I can graph an equation and points at the same time, so that'd be awfully hard to compare them that way. But honestly, there's still an easier way. We could just use a little bit of algebra, a little bit of math to figure this out. So when you're talking about the steepness of a line, which line is steeper? That's kind of part of the equation. That would be talking about the slope of the line. Remember, the slopeness of a line shows how steep the line is. So a slope of, well, actually, here, let's demonstrate. Actions speak louder than words, right? So if I do y equals, and I'm going to throw a little variable in here, plus 0. Okay. Oopsie, I need an x. I'm at a slider in here. So now basically what I did is I have this equation, and right now it's throwing a 1 in here for m. And I can take this slider here and I can drag it back and forth and watch what happens to the steepness of my line. As I make the m bigger, I make the slope bigger, my line is getting steeper and 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 steeper. And as I move my slider the other way, as I get closer and closer to 0, it's getting more and more flat. In fact, when I get to actually 0, it's a perfectly flat line. Do you know what's going to happen when I make the slope negative as I drag this slider to the left? Well, negative slopes go downhill. But it kind of follows the same rule. Like this guy here at -2 is just as steep as this guy here at +2. They're the same steepness. One's just going up and the other's going down. So the steeper a line is means that this slope is kind of farther away from 0. A slope of 10 is much steeper than a slope of -2. A slope of -8, there we go. Slope of -8 is much steeper than a slope of 3.5. Okay? So you can't just say the bigness of this slope. You can't say, oh, 3.5 is bigger than -8, so that's a bigger slope. No. It's whichever slope is farther from 0. That's what makes it steeper. Okay, so now if we come back here, let's check this out. Function b has a slope of -2. That is the steepness of his line. Function a's slope is, I don't know. I could figure it out, but I don't know just by looking at it. So here's what we do. We find our slope. M equals y2 minus y1 over x2 minus x1. That is our slope formula. I'm going to pick 2 points. I'm going to pick these 2 because I like small numbers. Makes this x1, y1, x2, y2. And that gives us y2 minus y1 over x2 minus x1. If this is unfamiliar, please check out the video on finding slope of a line. And then we do the math across the top. 15 minus 9, my brain doesn't feel like doing it right now, is 6. 4 minus 2, I can do that one, is 2. And I simplify, and I get a slope of 3. All right, so which of these two lines is steeper? A slope of -2 or a slope of +3? Which one is farther from 0? Function A. Function A has the steeper slope. And I can show that if I go back to Desmos here quick, I can, oopsie, I don't want that. If I have a slope of 3 and y equals 2x, the slope of 3 is the red one, is steeper than the 2. It's farther from 0. So a couple little extension questions based off that. Oh, I'm zoomed. There we go. What is the difference of the slopes? What is the difference? Well, difference means subtract. Typically when you subtract, you do big minus small. So 3 minus -2, the difference of the slopes would be 5. Their slopes are 5 numbers apart, from 3 to -2. Which function has the higher initial value? We haven't even looked at initial value. If you remember, initial value is your y-intercept. That happens when your x value is 0. Okay, those are background things we have in our head about initial value. So let's see. Function B's initial value is 15. So B is 15. A is, I don't know. Doesn't show it. I mean, I've got a set of points. I don't know when it's 0. Could we figure this out? Yes, we could. We could figure this out a few ways, but probably the quickest way is if we just kind of white out the x and the y here and go, what happens when he's a 0? Can I work this pattern backwards to figure this out? I know every time I go up 1 value in x, I go up 3 in y because that was our slope. And check out right here. Down 2, down 6. Here, let me actually write that. Make sense of this. Down 2, down 6. This was down 2, this was down 6. Now that doesn't quite work here because this one's down 3 and down 9, but it's the same ratio, right? Now here towards the end, I went down 2. Do you know what that number is going to be? Do you know how far I'm going to go down? Well, down 6. It follows the pattern. Down 2, down 6, down 2, down 6, down 2, down 6. Well, 6 lower than 9 is 3. So function A has an initial value of 3. So to answer the question, which function has the higher initial value? Well, function B has the higher initial value. What equation in slope-intercept form would represent function A? Okay, so we just want the equation. We already have the equation for function B. We want the equation for function A, which we can actually do now because I know the slope and the intercept for function A. We just found the y-intercept is 3. That is right here. That's the initial values, the y-intercept. And we found the slope right here was 3 as well. So this would be the equation y equals 3x plus 3. And just to show here something quick, if I type in y equals 3x plus 3, so I have Desmos here off to the side. This line right here will go through all of these points, or at least it should if we did this right. So does it go through the point 2, 9? It does. I can't get, oh, it was there. You saw it. I saw it. Does it go through the point 4, 15? 4, 15. Can I get this on projector mode? There we go. A little bit easier to see. 4, 15. I'm only going to do one more. 5, 18. So it is going through all of those points. All right. So that's a nice, interesting question. Letter B. Luke graphed the equation, let me try again. Luke graphed a linear function for the temperature change in his town from 12 a.m. to 12 p.m. Leah wrote the linear function given by the equation y equals negative 2x plus 1 for her town's temperature change. Which town started at a lower temperature? Could you do that problem, please? Could you pause the video and try that one right now? Which of these towns started at a lower temperature? The answer is Luke's town did. Luke's town, the initial temperature, that would be the initial value, which is the y-intercept, is negative 2. Leah's town, initial temperature, y-intercept, is positive 1. So which town started at a lower temperature? Luke's town did. Extensions. What is the major difference in the rates of the two towns? So it's not asking for like the difference as in subtracting the two things, but what is the major change in the rates of the two towns? What do you think? I want you to try this one as well. You're going to try all of this whole problem. So why don't you pause the video and think about it? Well, Luke's town, his temperature is going up over time. Leah's town, her temperature is going down over time. It's getting colder every hour, where Luke's temperature is getting warmer. So one goes up. Luke's is positive. Leah, how do you spell Leah? L-E-I-A. Leah's is negative. Okay. The last question of this one, it says at 6 a.m., which is 6 hours past midnight, 6 hours past when they started measuring, which town would have the greater temperature? At 6 a.m., which town would have the greater temperature? Go ahead and pause the video. When you're ready, continue, hit play, and we'll go through it together. All right, so at 6 a.m., who would have the greater temperature? Well, let's check out. I mean, I can see from Luke. So here's 12, 1, 2, 3, 4, 5, 6. His temperature would be 1 degree. So Luke's town, helps if you actually write, Luke's town would be at 1 degree at 6 a.m. Leah's town would be at, well, I need to use her equation. I'm going to take this equation, and I'm going to plug in 6 for the x variable. So y equals negative 2x plus 1. I'm going to plug in 6 for the x variable. That's 6 hours after the initial value. And we get y equals negative 12 plus 1 is negative 11. Leah's town is at negative 11 degrees. So which town would have the greater temperature? Luke's town would have the greater temperature at 6 a.m. So not too bad. Each of these things we can find, or each of these pieces of information we can find based off of the problem that is given. The next problem here says, Morgan and Steve leave school at the same time. Both travel home at a constant speed. Constant speed means it's linear, it's a straight line. The table shows the function that models Morgan's trip home. The graph, which is on the next page, shows the function that models Steve's trip home. Who got home first? So here's Morgan's trip home. I'll zoom out just a teensy bit for you. And there's Steve's trip home. Can you figure out who got home first? I want you to pause the video and think about it. Who do you think got home first? The answer is Morgan. Morgan got home first. And you're going, well, how on earth did you get that? Well, I can see this point right here. When Morgan's traveled for 10 minutes, she's at 0 miles from home. She's standing at her door. She's at home in 10 minutes. I can see Steve in 10 minutes. He is not quite home yet. He's still half a mile away from home. So 10 minutes, she's home. 10 minutes, he's not. Morgan got home first. So that's how I was able to figure out who got home first, is just by looking at the values and making sense of them. Whose house is farther away from the school? Who lives farther away from the school, Morgan or Steve? Well, that would be the initial value. So Morgan's initial value is 4 miles. At the beginning, before she starts walking, she is 4 miles from home. Steve, on the other hand, his initial value is 3 miles from home. So whose house is farther away from school? Morgan's house is farther away from school. I'll just put Morgan. So Morgan's house is farther away from school. 4 miles versus 3. Who's traveling at the slower rate? So we'd actually have to find the slopes of this, the rates of this, or maybe there's a way you can do that without finding the slopes. Who's traveling at the slower rate? Well, I'm going to do this the hard mathy way. Not really that hard, but I'm actually going to find the rate. I'm going to find the slope from Morgan here. So I'm going to use my slope formula. M equals y2 minus y1 over x2 minus x1. I'm going to plug in these 2 points because I don't want to deal with this decimal. It's not hard. I just don't want to deal with it. So I'm going to have x1, y1, x2, y2, giving me y2 minus y1 over x2 minus x1 is negative 4 over 10, which equals negative 2 over 5. That is her rate. Negative 2 miles per 5 minutes. So she's traveling home at 2 miles every 5 minutes. She's either a very fast walker, runner, or she's riding a bike or in a car or something. Steve. Boom, 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 boom. His slope is down 1 over 2. Except it's not down 1 over 2 because this is not down 1. This is from 3 to 2.5. That's not down 1. That's down a half over 2. Now we could maybe skip this one and go down 1 over 4. And now we're correct. Down 1 over 4. Down 1 over 4. That would be the slope. So now we can say, well, who is traveling slower? Was it 2/5 or 1/4? Actually, I'm a little unsure. So let's see. 2 divided by 5. She's traveling at a rate of 0.4 miles per minute. Steve is traveling at a rate of 1 divided by 4 is 0.25 miles per minute. Steve is traveling slower. Now that was kind of the hard way around this problem. we actually found the rates, the slopes of each of them, and went from there. We could have even said, I know Steve is traveling slower because he lives closer to the school, but it took him longer to get home. Morgan lives farther away, 4 miles versus 3. She lives farther away and got home first, so clearly she's traveling faster. Yeah, I would have accepted that too. Okay, so a lot of times there's different ways to go about it. It's creativity a little bit. It's not simply just following rules. It's thinking about the problem solving. What equation in slope-intercept form could be used to represent Morgan's trip home? Okay, so slope-intercept form, y equals mx plus b. Things, well, the slope we just found for Morgan was -2/5. Here's her slope, -2/5. -2/5 x. And her initial value was how far she was from home at the beginning of the problem, which was 4 miles. I remember it. It was right here. This is her initial value. The initial value is your y-intercept. It's what happens when the x value is 0. That's right here. So she started 4 miles from home. That was her initial value. Whoa. That is her equation. Okay. 1 for me, 1 for you. Carlos and Lily are each painting identical walls for their painting service. Carlos has painted 300 feet squared, that's an area, and plans on painting 150 feet squared each hour to finish his wall. Lily's plan for painting can be represented by this equation, where x is the number of hours and y is the total amount of wall painted. Who is painting their section of wall faster? If you could please pause the video, do this problem right now, and when you're ready to continue, hit play and we will go through it together. All right, so I'm going to get myself a little organized here. So Carlos and Lily. Lily's equation is y equals 180x plus 200. I could actually take Carlos's information and write it into equation very easily as well, because Carlos has painted 300 feet squared. That's his initial value. He already has that much done. And he plans on painting another 150 foot each hour. That's his rate, 150 feet each hour. So now, who is painting their section of wall faster? I'm looking for a speed, which is a rate, which is the slope. Which slope is bigger? Carlos or Lily? It's Lily. Lily is painting faster. 180 feet squared per minute versus 150 feet squared, actually per hour. Extension questions, you ready? What? There they are. Who had more of their wall painted initially? So at the beginning of the problem, who had more wall painted, Carlos or Lily? Pause it and do it. When you're ready, hit play. Should have said Carlos. Carlos initially had more painted than Lily. He had 300 feet done in the beginning. She only had 200 feet done. So Carlos has more wall painted than Lily. What equation in slope-intercept form could be used to represent Carlos's painting of his wall? Well, we kind of already did that one because I wrote the equation already. It's this. That's the equation because that was his rate. That was his initial value. So we were able to write the equation. So sorry I did your question for you. Y equals 150x plus 300. Oh, good. There's more. Haha. If Carlos and Lily's walls were 600 feet big, so if they had like a new wall that was 600 feet big, who would finish painting their wall first? Would Carlos finish first or would Lily finish first? And I guess this is not a new wall. This is the wall that they're painting from the original problem. Who would finish first, Carlos or Lily? I'm going to scroll back up so you can see their equations. Pause if you need to see this. All right. So who would finish painting 600 feet square of wall first, Carlos or Lily? Go ahead and pause the video now and do this on your own. Okay, I actually don't know the answer to this question, so I'm going to do it. But the way I would do this problem is I would actually write out their equations. So y equals, this is Carlos, 150x plus 300. Lily was y equals 180x plus 200. And I want to know who would finish painting 600 feet first. So you know what I'm going to do? I'm going to plug in 600 feet squared for the feet squared variable, for the wall painted variable, which is the y variable. X is our hours variable, 180 feet per hour. This dude paints at 150 feet per hour. So I'm not going to plug in 600 for the hours variable. That's going to give me a very big number. How much they painted in 600 hours. Don't want that. I'm going to plug the 600 feet in for the wall painted variable. So check this out. If I plug in 600 here, 180 x plus 200, and solve this little equation, I might need to make my marker smaller and write a little bit smaller. So I'm going to subtract 200 on both sides. 400 equals 180x. I'm solving this equation, so I divide by 180 on both sides, and I get x equals 400 divided by 180 is, it would take Lily 2.2 repeated hours to paint 600 feet of wall. Okay, now let's check out Carlos. I'm going to plug in that same 600 feet in for Carlos. And I'm going to solve this equation. So I'm going to subtract 300. I'm trying to get the x variable by itself, the hours variable. 150x equals 300. Divide by 150 on both sides. These cancel out, and I get x equals 2. I can divide that in my head. Is 2 hours. So who would finish painting 600 feet of wall first? Carlos would. He would finish in 2 hours. She would finish in 2.2 hours. Carlos would finish first, just by a teensy bit. This is a nice little fancy extension. This last question here says, if Carlos and Lily worked together at their same rates, so Carlos is still working at his 150 and she's working at 180, and they were going to paint a new wall that is 1,000 feet big. So they're working together on this 1,000-foot squared wall. How many hours would it take them? Okay, so I'd like you to pause the video, do the problem right now, figure out how long it would take both of them to paint one wall together that is 1,000 feet squared big. When you're ready to continue, hit play, and we'll go through it together. All right, so I'm going to kind of make an equation here. How much space do I have? Not a whole lot. So I'm going to use the small marker still. So y equals mx plus b. So let's think about the things I know. Do I know how much total wall they need to paint? Yes, I do. I'm going to plug in 1,000 for my wall variable, how much they painted variable. Do I know the rate that they will paint? I do. I know they're going to paint at 150 plus 180 together. I'm adding their speeds together. They're working together. So, I mean, if Carlos is painting one side and Lily's painting the other, together they're painting at this total rate. Do I know the amount of time it's going to take them, the x variable? No, because that's the whole point of the problem. Do I know how much wall they have painted at the beginning of this problem? I do. None. They just started a brand new wall. They have no wall painted yet. So this equation would simplify down to 1,000 equals 330x. Let me double check my 180 plus 150. I don't want to be wrong. All right. I'm not going to put plus 0. I don't need plus 0 here. And now I divide. I'm going to solve. Divide by 330 on both sides, and we get x equals 1,000 divided by 330 equals 3.03, I'll round it right there, hours. So it would take the two of them just over 3 hours to paint 1,000 feet square of wall. Letter C. You did the last one, so I'll go ahead and I'll do this one with you. It says Donald is comparing two cell phone plans that charge by month. Let X represent the number of minutes used, so that's our X variable. X is the number of minutes used over 500. That's kind of important. And Y represent the total cost in dollars. Cost in dollars. The cost from AT&T is represented by this equation. All right. The cost from Verizon is represented by the graph. And you're going, what graph? Well, that graph. The question is, which plan charges more per minute over the 500 minutes that are included? Okay. So cost per minute, that is a rate. That's not the initial value. That is the rate. So I can see right now, AT&T, I can use my bigger marker now, AT&T charges you 35 cents per minute once you go past that 500 minutes that they give you initially. Okay, that's the rate they charge, 35 cents per minute. By the way, these numbers are completely fake and made up, so no lawyers sue me. I'm just making up numbers for the math problem. All right, back to the problem. The rate for Verizon, I don't know. I can figure it out because I know how to find rate from a pretty picture. I can find where my line is going through these lattice points, these little crisscrossies. I can count the way my slope moves, up 1 over 3, except it's not actually up 1, that's up some weird number. It's up 2.5. That's a little wonky. So you know what I'm going to do? I'm going to go up a little higher. I'm going to try that. That is up 5. I can see that clearly from 15 to 20. That is up 5 over 1, 2, 3, 4, 5, 6. And 5 over 6 as a decimal is 0.83 repeated. So I'm going to say Verizon charges 0.83, so 83 cents per minute, where AT&T charged 35 cents per minute. So now to answer the question, which plan charges more per minute over the 500 minutes that are included? Well, Verizon charges more per minute. 83 cents versus 35 cents. Extensions. What does the y-intercept of the functions represent in the situation? What does the y-intercept mean in terms of minutes and cost in Verizon and AT&T in dollars? Don't say initial value. Don't say anything. What does it mean in terms of these variables? Well, the initial value is the total cost if you have not gone over 500 minutes. If you're over 500 minutes, is 0. So if you don't go over that 500 minutes, that's your cost. That's, I guess we'll call that the monthly plan. What does it mean? It's just the monthly plan. Ooh, that was ugly. Let's try it again. Monthly plan cost. As long as you don't go over 500 minutes. What equation could be used to represent Verizon's total cost, y, after using x minutes over 500? That's actually not too bad because we already found the slope. The slope was 0.83. We did that here. 0.83 was the slope. So now what would be the equation for Verizon? Well, we have the slope. The only other thing we need is the y-intercept. Can you see that in the picture? Yeah, it's 15. So the equation would be y equals 0.83x plus 15. So I can say if you used 10 extra minutes, we'd take 0.83 times 10 and then add on that $15 charge, and you'd be paying $23.30 that month. Oh, that's a really cheap monthly bill, isn't it? Better than the couple hundred people pay. Continuing on, which company would cost less if you only used 200 minutes a month? I want you to try that one. I want you to pause the video. I'm going to scroll back up here for you in a second. But the question is again, which company would cost less if you only used 200 minutes a month? So now you can see the equation, you can see the graph. Which company would cost less if you only used 200 minutes a month? Pause the video, try that one on your own right now, and when you're ready to continue, hit play, and we'll go through it together. All right, so the answer is going to be Verizon would cost less. Because if you only used 200 minutes, you're never going over 500. You're not going 200 minutes past this point. You're only using 200 of the 500 minutes. So if you don't go over 500, Verizon would charge you $15. If you never go over the 500 minutes, they don't charge you this 35 cents at all. So AT&T would charge you $20. Verizon would charge you 15, AT&T would charge you 20, as long as you don't go over the 500 minutes. So the answer is Verizon. And I think this is actually the last question. It is. What would be the difference in the costs of both companies if you used 600 minutes? So if you used a 600-minute month, what would be the difference in the costs from the companies? If you used 600 minutes in 1 month, what would be the difference of the costs? Go ahead and pause the video and try this one on your own. If you use 600 minutes, what would be the difference of the costs? All right, so for AT&T, we would take this equation, y equals 0.35, and in for the minutes variable, that x is our minutes, we'd plug in 100. Going, what? No, we're supposed to plug in 600. No. X is the number of minutes over 500. Well, how many minutes over 500 is 600? It's 100 minutes over. So then if we do the math here, and I can use my handy dandy calculator. Actually, I lied. I don't need to. This is going to be y equals 35 plus 20. Y equals $55. They're going to charge you that month. All right. Verizon. I'm going to do the same thing. Y equals 0.83 100 minutes extra plus 15. And where did that come from? Well, that's the initial value right here. So the initial value is $15, 83 cents a minute after the $15. So if you used 100 extra minutes, y equals 83 plus 15, that is 0.83 times by 100 is 83. Y equals $98. So to answer the question, what is the difference in the cost? 98 minus 55 is $43. So it would be a $43 difference in cost for each company if you used 600 minutes. All right, summary. When comparing two functions, what are some possible criteria? What are some things you can look at when you're comparing them. Think back to the lesson. When we were comparing these functions, what were the features of the functions we were looking at? How did we compare them? Well, we looked at two main things. We looked at the slopes and the intercepts. If I scroll up here, who is traveling at a slower rate? That's the y-intercept. I'm sorry, that's the slope. Whose house was farther away? That was the y-intercept. If we're talking about this one, what is the difference? The difference in the rates. That is the slope. This one was based off the equation of both functions. So I guess you could talk about the equation as well. Who had the higher initial value? Well, that's the y-intercept. What is the difference of the slopes? That's the slope. So the main features you can compare are going to be the slope and the intercept. Those are the features of an equation, features of a linear function. Slope and intercept. Okay? So thank you much for watching this lesson on comparing functions. Until next time, toodles.